Hi, I'm Dr. Daniel Lester, Facility Manager for the Polymer Synthesis and Characterisation Research Technology Platform here at the University of Warwick. Our facility is concerned with the analysis of polymers by a number of means. We are located predominantly in 3 labs, each loosely divided into GCSC for gel permeation chromatography or size exclusion chromatography, thermal analysis and particle sizing. However, this is by no means the full extent of our capabilities. More on this later. First up is our GCSC Lab, which contains 7 state-of-the-art instruments, including a high-temperature model. This technique is the de facto leader for measuring molecular weight distributions of soluble polymers by separating them on a column by their hydrodynamic volume in solution. Using advanced detectors, we can also obtain information on architecture and branching, for instance. Solubility is key, and for this reason we have a number of instruments full-time in DMF, water, chloroform and THF, and even TCB for high-temperature applications such as polyethylene or polypropylene. This lab also contains an AF4, asymmetric field flow fractionation instrument, capable of separating and sizing nanomaterials. In our thermal analysis lab, we have several different instruments. We have 3 DSC, differential scanning calorimeters, for measuring phase transitions of materials such as glass transitions and melts. Between these 3, we can analyse materials between -150 and +500 degrees C, in even nitrogen or air atmospheres. We have 3 TGAs, thermogravimetric analyzers, measuring the decomposition and degradation pathways of materials, including one with a mass spectrometer to identify any effluent during heating. We have 2 DMAs, dynamic mechanical analyzers, for analysis of thermomechanical properties, with a sensitivity generally much higher than that of DSC, where we can host materials of many different types. We also have a Rheometer with plate-plate attachments to measure the viscoelastic properties of materials such as oils, rubbers and films. This makes it very complementary to DMA and mechanical testing. Moreover, we also have a tribology attachment for measuring friction of materials. Our third lab is concerned with particle sizing. We have 2 DLS instruments for measuring particle sizes in the region of 1 to 1,000 nanometers using the principles of Brownian motion. We can also use these instruments to measure zeta potential, which is an indication of surface charge and stability. Further, we have a particle size analyzer, which can measure particle sizes of water dispersible materials in the region of 100 nanometers to 500 microns by the principle of laser diffraction. We also have a mechanical tester to measure the tensile and compression properties of materials up to 500 newtons, making it very sensitive to polymeric materials such as gels and rubbers. This is very complementary to the DMA and the Rheometer in the previous lab. This lab also contains our IR instrument with ATR cell. This is mainly used for chemical identification of materials. It is non-destructive, requires minimal sample, and measurements are very speedy. Last but not least, we have a drop shape analyzer, where we can assess the properties of surfaces and liquids. Typical applications are to measure the hydrophobicity and hydrophilicity of surfaces by placing a controlled volume drop on them and measuring the contact angle with the surface. Finally, we have a number of instruments based in other labs, such as GCFID for separation and quantification of volatiles, HPLC for separation and quantification of not so volatiles, some 3D printers, and a high temperature furnace for sample curing and annealing. We also have access to wet chemistry labs that we can perform bespoke polymer synthesis. We have a small staff, where between us we have many years of experience in polymer chemistry, analytical science and materials science. And although primarily concerned with polymer analysis, we are happy to turn our hand to any materials that are suitable with our instruments, for instance metal oxides, composites and proteins. For more information, please visit our website or get in touch directly. We'll be happy to discuss your needs and try and help.